Hey guys, I am working through the 1.14, 1.15 limits to infinity delta math assignment, doing some example problems from these question types that we'll be tackling. I do have pulled up over here just like mini whiteboard or scratch paper, so that way I can work out some of my thought process. This will just help me explain some of these questions. So let's go ahead and we'll start with this first question type, limits to infinity type 1. All right, so in this problem, I have the limit as x approaches infinity of all of this junk. I only have polynomials occurring, and you basically need to find where the largest degree is going to happen. And so normally if I FOILed this all out, right, I know that the biggest degree I would ever get would be when I multiply the x squared times the x squared. And so if all I have to worry about are multiplying these last terms together to figure out what my coefficients on that would be. So for example, if you do 4x squared times negative 2x squared, I'd end up with a negative 8x to the, wow, that is really thick. Hold on a second. Negative 8x to the fourth on top. There we go. And then on the bottom, when I do the same thing, the largest degree I'd end up with, again, would be when I multiply my last terms together. So my negative x times my negative 2x cubed. When I do that, I'd end up with a positive 2x to the fourth. And so since those would be my largest degree, I can just ignore everything else that would ever happen because those will grow much faster than my just x squareds or anything like that. So then I take, and because they match, I take their coefficients. So my answer, my limit here would be negative 4 because negative 8 divided by 2. Voila. They actually went and FOILed it all out, but like I said, I don't really have time for that. Term with your highest power. Yep. There you go. So let's go ahead and try another one. All right, we can do the same thing for this problem. Is we're just going to compare where our highest terms, or excuse me, our highest degrees would end up being. And so I can kind of see on the top, so my highest degree I'd get on the top if I FOILed everything out would be a negative 4x cubed times my 8x cubed. So that would end up giving me a negative 32x to the 9th. Nope, 6. Got it. And then on the bottom, my largest degree that I would end up getting would be 8x squared times 8x squared. So that would end up getting me 64x to the fourth. And so since my largest degree is on top, I know I'm going to go towards infinity or negative infinity, and I just have to pay attention to what I'm approaching, as well as my exponent, as well as if it's multiplied by a negative number or not. So if I have, I can ignore this part now, if I have an infinity to the 6th, that's positive, but then I multiply it by negative 32, and that would end up giving me a negative infinity. Or D&E in this scenario, because I don't think they'll let you type in negative infinity. Oh, yep, there you go. It's unbounded. Wow, they're going to make it extra easy on you. You're just going to have to say D and E anytime it ends up being infinity. Lucky ducks. All right, let's do one more. All right, and this example, we do the same thing. So we're going to compare the highest terms that you would end up getting on the top and the bottom. So let's say on top, the biggest term would happen when I did negative 4x times 6x. So I'd end up with negative 24x squared. And then on the bottom, the biggest thing would happen when I did x times x. So that would give me just an x squared. And so then your answer would be the coefficients, so negative 24. Voila. Again, they go through the whole process. So. All right, let's go back and we'll try some, more of the second type of problems. Oh, look, I did all of them. All right, so for this one, it looks like you have to pay attention to the roots that are happening. So this is a cube root on this thing. And when I do that, my biggest thing that I'll have to pay attention to, let's see. So I have a 64x to the 11th, it's the biggest in the top. And then when I have the cube root of that, I'd end up with 64x to the 11 thirds. Would technically be what happens, right? That would be my biggest root that I have, or my biggest exponent I have. And then on the bottom, I have an x cubed, which if you need to compare, 11 thirds is greater than 3. So as this approaches infinity, then my whole function would also approach infinity, or DNE. Voila. See how they worked it out? Oh, shoot, I guess I forgot the 64 part. It would just be 4. Which is going to be important if they matched, right? So there we go. All right, and this next one, let's look at one more example of this. We have, let's see, my biggest term in the in the top I have to care about is a 16 x to the 6. And then on the bottom, the biggest thing I have to care about is my 8x cubed. And so when I simplify that, you'd end up with 4x 6 over 2, which would be 3. So 4x cubed over 8x cubed. And then since they match, 4 over 8 is 1/2. There you go. All right, so those ones are pretty self-explanatory, I think, now that we've kind of got the swing of things. All right, let's try this next type. Oh, this one just looks like a multiple choice problem. Okay, so the statement best describes the limit shown below. So the limit equals 0, the limit does not exist, or the limit exists and does not equal 0. So you don't have to actually find the limit, you just have to tell me which one of these things happens. So I have, let's see, the only part I have to care about, is an exponential function. So as that goes to infinity, that means the bottom of my fraction will get super big, which means my whole fraction will get super small. Boop, boop. There you go. Try another one. All right, and this one, the same thing happens, right? I want to only pay attention to my exponential part, and so as my exponential part gets really big, my bottom of my fraction gets really big, which means my whole fraction gets really small. So the limit equals 0. Voila. Let's do one more. These ones are easy. Oh, same thing again. Come on, you keep throwing exponents in, or exponential functions in there. Obviously, the limit's going to equal 0. There you go. I wonder if I can do another one. Okay. Oh, no, I can't. It literally won't let it happen. Oh, yeah, there we go. Let me do another one. So in this one, I don't have any exponential functions. So I look at my highest polynomial. So x to the 85th, x to the 85th, those match. And so you use their coefficients. 8 divided by -2, is -4. Limit exists and does not equal 0. There you go. And then it tells you how to actually do it. All right, we got one more we got to do, limits to positive or negative infinity. So let's work through some of these guys. Determine whether the following limit is equal to infinity, negative infinity, or some specific value. So this time you don't get off as easy by just telling me that the limit's D and E. You actually have to verify which one it works with. So let's see. For this one, the only parts I care about are the x to the 5th and the x to the 5th. They match, so I use their coefficients. 6 divided by -1 is -6. Excellent. Big to the 5th, big to the 5th. I like that they use that. All right, for this one, let's pay attention. Oh, I'm going to work out a little bit of this one. So for this one, you're approaching infinity. And so first and foremost, you're probably looking at this exponential function. So let's pay attention to what happens if I plug in, quote, end quote, infinity here. So we'd have 2x plus e to the negative x plus 1. So if I have e to the negative infinity, quote, plus 1, this is e to a giant negative number, right? Which is technically, when you have a negative exponents, 1 over e to the positive infinity. Now, and as the bottom of my fraction gets increasingly large, my whole fraction goes to 0. And then I'm still using, technically I should still be using my infinity over here as well. Oops. So it still should be 2 times infinity, quote. So this whole thing actually goes towards 2 times infinity, which is infinity. Cool. All right, let's do another one of those. I like these ones. For this one, let's do, so we're going towards infinity. And again, I'm paying attention to this exponential at first. So it looks like I'll do 6 minus 6 times infinity cubed. And then e to the negative infinity. Well, really, this turns into 6 minus 6 infinity cubed times, oops, I guess there was parentheses around this, wasn't there? 1 over e to the infinity. And remember, as e to the infinity, the denominator of a fraction gets really big, the whole fraction gets really small and goes towards 0. And so you're taking a negative infinity and then you're multiplying it by 0. I'm pretty sure that ends up being 0. Yep. Right? So this is a very negative number, but then e to the negative infinity is 0. And so you're taking a negative infinity, negative something, and multiply by 0, and you still get 0. Cool. All right. So those are probably the hardest ones, but I also like those ones because they require the most just kind of like work in your mind and not as much in the math. So let me know if you have any more questions about these, and I will get back to you.